Okay, for this worksheet for homework, we're now going to be practicing triangle similarity proofs. So we spent all last week on congruence proofs. Now we're going to be doing similarity. So remember that we have three new postulates. We've got angle-angle similarity theorem. We've got side-angle-side, where the angle needs to be in between the two proportional sides, side-angle-side. And we've got side-side-side, where you have three proportional sides. So let's go take a peek at what we have to prove that these triangles are similar. Okay, so taking a peek at this first one, notice that three sides are marked. We've got, let me use three different colors here. We've got this side, which we're going to look to see if it's proportional to this side. Remember, we need three equal side ratios. We've got this side and this side. And finally, we've got this bottom side to this bottom side. So let's go take a peek and see if these actually work with the three proportional side ratios. So we can say side IE, actually I'm going to need way more space, hang on. Side IE compared to side FR is going to be 12:4 ratio, which is 3. Then we have side ER compared to side RA as a 21:7 ratio, which equals 3. Then we have the purple side, which we would say IR compared to side FA, which is 24:8, which is 3. Because we have three ratios of corresponding sides, we can say that they are similar by side, side, side. So here I go with the triangle names. Triangle IER is similar to triangle FRA by side, side, side similarity theorem. We do need to fit that whole thing in here. Hang on. Side, side, side similarity theorem. The reason we have to write similarity theorem is because there is already a side, side, side congruence postulate. So we have to specify that this is the similarity theorem instead. All right, let's go do the next one. This time I'm noticing a side and an angle and a side. Okay, so we're looking at SAS this time. All right, so the first side ratio would be DV, DV compared to BN is a 20:4 ratio, which reduces down to 5. Then we've got the other red is an angle. We can say angle V is congruent to angle N, and that was given in the image. And then finally, we could talk about the next side ratio, VA compared to NE, and that would be a 25:5 or a 5. Notice that these two ratios of corresponding sides are equal, so we have a side angle side relationship going on here. So we say that the triangle DVA is similar to triangle BNE by side angle side similarity theorem. Up here, this was given. These angles are congruent based on it being given in the image. And then we also used the ratios of corresponding sides. Notice I'm not doing a formal proof this time. We're just kind of writing the work wherever we can fit it. It's not asking for a formal proof. Okay, next one has two angles. This is our AA similarity theorem, right? Two angles. So I'm going to do angle C is congruent to angle R. It was given in the image, this guy and this guy. And then notice that this next one, 66 and 78, they're not equal. So real quick, I need to do a subtraction here. I need to do 40 plus 66, and that gives me 106. And then I need to subtract that from 180 to see what this missing triangle is. So that's 474. And over here, if I do 78 plus 40, I get 118. 180 minus 118, I'm getting 62. So looking at that work, do we have triangle similarity here? Do I have two angles that are equal? Nope. I'm going to write no other angles are equal, so therefore not similar. Okay, so we do not have our two angles because they are not equal. So these two triangles are not similar. So what do we write in that case? You would write not similar. You would write, you could actually write out the triangle names. Triangle CON is not similar, so you can put a slash through to RST. So you could put a slash to designate that they are not similar. Does that make sense? Or you could just write it out. Okay, anyways, let's go down to the next couple. So you should be getting used to the side ratio concept now of how we write out the sides. Okay, so over here, I'm noticing that I have side SA compared to side RE. So that's going to be a 4:10 ratio. Then I've got angle A is congruent to angle E. That's given. And then I've got IA compared to FE, which is a 10:25 ratio. If I reduce this down by 5, I get 2/5. Notice that the 2/5 is in both places, so I can use those two ratios of corresponding sides. And this is going to be by side angle side similarity theorem. Triangle ISA is similar to triangle FRE by side angle side similarity theorem. All right, this next one has 3 sides. Let's go do those side ratios and see how it's looking. OA compared to NA would be 28/7. WO compared to SN is 36/9. And finally, WA to SA is 60/15. Because I have 3 ratios of corresponding sides, I can say that triangle WOA is similar to triangle SNA by side-side-side similarity theorem. What's my reason? Ratios of corresponding sides. And that works for all three of those. Okay, next one has a sneaky vertical angles. Do you see it? This guy right here is equal to this guy right here. By vertical angles are equal. So that's what we need in order to do this guy. So I'm noticing a side, an angle, and a side, and the angle is in the middle of the two sides, so let's try it. WN over HN would be 7 over 35. Angle WNI is congruent by angle HND by vertical angles are equal. And then finally, side IN compared to DN is 6 to 30. You'll notice the 1/5 on both the top and the bottom, so I can use the ratios of corresponding sides. And I can say that triangle WIN is similar to triangle HND by side angle side similarity theorem. Now, as you're doing these, I'm really hoping that you're pausing the video and trying them on your own and then checking your work after. Okay, part G. We have sides and an angle. Let's check these out. So we can say side PE to side LS. But then we stop because we notice the angle is not in between the sides. So then we're going to say triangle PEG is not similar to triangle SLR because it cannot be determined. And why is that? Because the angle is in the wrong place. The angle has to be in between the two sides. Okay, so letter G is another cannot be determined. Okay, looking at this next one, we have to realize that this entire length is 18. Does everybody see how I got that? That 8 and that 10 add up to 18. And then on this guy right here, this 12 and this 15 makes 27. What's happening is we're comparing this bigger triangle compared to the inside triangle. Okay, so you have to know those bigger side lengths in order to get ready for this one. And we can tell that both these triangles have this same angle right here. So we can start by saying that angle T is congruent to angle T because it was given in the image that they literally share that angle. Now let's do the side length of TH. TH is the little side of 10 over TI. So I'm doing little to big. So that's 10 compared to 18. And then I'm going to squeeze it down here. The other side length is TO. Color, let's do pink. TO, it's the little side on the bottom of 15 compared to TB. So 15 compared to 27. So let's reduce these down. 3 goes into 15 5 times. 3 goes into 27 9 times. Looking at the other one, 2 goes into 10 5 times. 2 goes into 18 9 times. Do you guys see that they do have the same side ratio of 5/9? Yay! So they are similar. So we can say that triangle HOT is similar to triangle ITB by side angle side similarity theorem. So it's like a triangle inside of another triangle. Be careful with those. All right, next we're looking at two triangles that are separated from each other, but we have 3 sides given. So let's see if the corresponding ratios work. So SE compared to RD would be an 11/22 ratio. Let's do ST over RO is a 9/13.5 ratio. Uh-oh, you noticing something here? And then finally, we have this guy down here, TE to DO is a 4:6 ratio. So I've got 3 different side ratios, 9/13.5, 1/2, 2/3. So I would say that triangle STE is not similar to triangle ROD. And how come? Because the ratios of corresponding sides are not equal. Okay? All right, how'd you do? Now, on the next page, we're not only going to be proving similarity, but we are going to then solve for x using a proportion. So we're going to use a proportion to solve for x. So let's first prove that they're similar. Now, looking at the first triangle, do you see these marks right here that mean parallel? When we have parallel lines like that, we know we have alternate interior angles. So I can say that angle E is congruent to angle N by alternate interior angles being equal. Now this only works when I know that the triangle, that I know that the sides are parallel. So you have to put this mark. They are parallel, so alternate interior angles are equal. Next I can say, you see the other one staring at you, that angle EUC is congruent to angle NUG. And the reason for that one, do you know it? Good, is vertical angles are equal. Remember that for triangle similarity, I only need 2 angles. There's my 2 angles. So now I can say that triangle EUC is similar to triangle NUG by a similarity theorem. Now that we know that they're similar, now we can solve the proportion. So here I go. I'm going to say, notice the side lengths that have numbers, and I'm going to go small to big. 2 is to 5 as, I went small to big or left to right, so x minus 1 is to x plus 5. I'm actually going to write this up here because I'm going to run out of space. So 2 is to 5 as x minus 1 is to x plus 5. And now we're going to cross multiply to solve this. Middle school skill here. So I'm going to get 2 times the quantity x plus 5 for my first diagonal. And then I'm going to get 5 times the quantity x minus 1 for my second diagonal. Then we are going to distribute. And then we're going to solve. Move the x's over. Move 5 over. I'm going to get 15 on the left is equal to 3x. And then we divide by 3. And we get that x equals 5. So on these problems here on the back, you're going to do 2 things. You're going to prove that they're similar, and then you're going to solve for x. What do you think? How'd you do? Okay, let's go do part B. So I can see that these 2 lines are parallel. So parallel lines have corresponding angles. And I've got some, let's see, what else do I have? I have this angle right here that is shared between both. Okay, so what am I going to say in my proof? I'm going to say angle W is congruent to angle W by the reflexive property. It is literally equal to itself. And then I'm going to say angle WNO is congruent to angle WBR by corresponding angles are equal. That is only true with parallel lines. So you have to put this parallel lines mark, letting me know that you said because they're parallel, corresponding angles are equal. And therefore, we can say that triangle WNO is similar, so the little guy is similar to the big guy, triangle WBR, by a similarity theorem. Now that we got to the point that they are similar, now you can solve by a proportion. So how do I solve by a proportion? I'm going to go like this. Remember that we have to notice that this big side is 8. How did I get that 8? The 3 plus the 5. So I'm going to say little is to big on the left side as little is to big. Notice that this side length is x plus 6. There's the x, there's the 6. And I am going to need to write that way smaller so I can fit this work in. So again, we go little is to big as little is to big. Oops. Okay, now I'm ready to cross multiply. For my first diagonal, I get 8 times x. For my second diagonal, I get 3 times the quantity x plus 6, and then we can distribute. 3 times x, 3 times 6. I'm getting 5x equals 18. So my answer is just going to be 18 over 5. And you can leave it as a decimal or a fraction, however you prefer. Okay, last one that I'm going to do with you, and you're going to try the last 3 on your own. So for this one over here, notice we have this angle. And notice that we have this side and this side that are given. So I'm going for a side angle side proof right now. So I'm going to say side RO compared to side MI would be a 5:3 ratio. And then I'm going to go angle R is congruent to angle M. It was given in the image. And then I'm going to say side RG compared to side MC is 15:9. Let's reduce this down. 5 goes into 15 3 times. I'm sorry, reverse that. 3 goes into 15 5 times, and 3 goes into 9 3 times. Notice that our two side ratios are equal. So we can say that triangle ROG is similar to triangle MIC. Don't forget the triangle sign. By side angle side similarity theorem. Because I proved that they're similar, now I can do the ratios in order to solve the proportion. So we're going to say, and you can use either side here, it doesn't matter, but I'm going to go big is to small, 5 is to 3, as x plus 8 is to 2x minus 10. And so now I'm ready to cross multiply. I'm going to get 3 times the quantity, x plus 8, for my first diagonal. And then 5 times the quantity, 2x minus 10, for my second diagonal, which when I distribute gives me 3x plus 24. And then 10x minus 50. Move the x's together. Move the 50 over. I'm getting 74. When I divide that on my phone calculator, 74 divided by 4, I get 18.5 as my decimal. Okay, all this work was from part C. Sorry that I had to squish it over there because of my big writing. I would like you to try part D, E, and F on your own now. See if you can prove the triangles similar, and then get the proportions to solve for X on your own. I'll be going over the answers on Monday, first thing in class. So that was X equals 18.5. Again, all this work is for part C. Okay, how'd you do?